All right. Morning. So it's the second part of evaluation. So we'll be talking about a little bit more serious stuff for user evaluation today, which is mainly the formal methods that you might need to run for your thesis. So hopefully it will be helpful for you to plan out your user experiments after learning the stuff I talked today. So just to recap from what we talked about last time. So we started with what evaluation is in terms of under the context of human-computer interaction research. And we kind of briefly talked about, it's basically about gathering the data about the quality of your user interface design, which is mainly measured by the usability, the term called usability, and how useful or how easy it is to use your user interface. And we talked about there are different aspects of usability. So it's not one single measure that you can point to, but you'll have to think of different aspects of usability when you evaluate your user interface. And then although it usually comes at the very end of your process, it doesn't necessarily mean that the evaluation is the end of your HCI research, but it's usually to have a feedback so that you can go back to some of the steps to iterate your design process so that you can improve your user interface design. And so then we went through briefly, I think we talked about expert-based evaluation and user-based evaluation and so forth, but we said we'll be mostly focusing about user-based evaluation, which is user study. And this was the brief overview of the process. You do the user study, which is first, the very first important step is to set your goal, what you want to know or find out from your user study, which is summarized by setting a research question that you have at the beginning of your planning, and then let your users experience or try out your user interface design, and then collect the feedback from there. And by feedback, we talked about different types of feedback, such as qualitative feedback, that's a written feedback, and quantitative feedback that you can measure in numbers so that you can crunch them using statistics tools. And after that, you analyze the collected feedback, and then based on those feedbacks, you try to answer the research questions you had at the beginning. So we talked about there are different level of details when you set out research questions. So at the early stage of research, you might have a very high-level questions, but later on, as you go on into more specific in your design, you get more specific questions about your research as well. And today we'll be mostly focusing on a little bit more detailed research questions. And depending on your research questions, you can use different types of user study methods and observation, interview, survey, those kind of types you can apply into your early stage of your research process. And in many of the cases, these studies are focusing on qualitative feedback or descriptive feedback of your user interface, while the latter methods such as usability testing, experimental studies look into more formal type of user study. And again, not one of these are the one method that you will have to use. So think of mixing and matching. So at the early stage, you can use some observation and interview, and then later on, as you develop more solid prototype, then you can do usability testing or user experiment. And I think I've briefly mentioned this. So qualitative feedback, quantitative feedback, and also the feedbacks also can be categorized into objective feedback and subjective feedback, which is objective measures are you can based on observation and it's more generalizable, while subjective fit measures are based on users' opinions and it doesn't necessarily mean that subjective measures is always written form, but you can ask them to rate or rank certain options so that you can quantify them and make it into numbers. Okay. So I think I've briefly covered those. So today we'll be mostly focusing about the latter two methods, which is usability testing and user experiment. And as you can notice here, usability testing is still categorized under descriptive or relational investigation rather than experimental investigation, which is the main difference is user experiments are looking into causal relationship, looking into which causes which means if you give different interfaces, does it cause to result in having faster task completion time or so? So user experiments are focusing those causal effects. Usability testing are more into descriptive investigation, which means how useful is this, or compared to the standard, how bad is the user interface, and so forth. So we'll start from the usability testing side. So I think we all know what does usability means by now, and since the word is saying usability testing, is basically testing how useful or usable is your user interface. So the main goal is to identify some issues or problems that your design has, and to fix those problems so that you can make your design better. And there are mainly three approaches. I think we briefly talked about this when we talked about evaluation in general. But usability testing also can be done in three different approaches, which is user-based testing, which is inviting users and let them use and see what's making problem in terms of usability. Expert-based testing is inviting experts and let them try your user interface design and let them find out what are the problems again. And by this, experts usually use heuristic rules, which is previously studied in researches, so that they can compare your interface to those heuristic rules and see if your user interface design is either violating some of the rules or if it's right according to the rules, those heuristic rules. And automated testing, there are also software tools that usually automatically checks some of the rules. And this is more systematic way, so it needs a systematic input, which is in many cases it's applied to web design rather than other types of user interface design, because web design, you have an HTML code that the system can parse and see if some of the fonts are too small, or if the layout is too, if the navigation between the pages is not making sense, and so forth. So in early 2000, there has been some software tools that you put your website, and this tool kind of analyzes how useful is those design. But I think these kind of research kind of died out a little bit these days. But anyway, so some of the tools are these tools, but those have been not much getting updates recently. But anyway, that's one of the approaches. And more recently, I think Android, when you are familiar with Android development, in Android, they also use XML files to create user interfaces. And they have a tool called Lint, which is not only for usability testing, but also in general kind of testing the grammar of the XML and so forth. But as a part of that Lint tool, it also provides some feedback in terms of usability, such as if there is an image button, then it recommends you to add an alternative text description of that image, so that the impaired person could at least be informed what that image is about and so forth through verbal text-to-speech feedback and so forth. So those are kind of looking into a little bit more of automated testing, but we won't be talking too much about automated testing, but we'll talk about these two methods. So coming back to expert-based testing, So it's having an expert who is familiar with usability usability heuristic rules, so that they can identify the problems easily. So one way to do this is to have a set of heuristic rules and compare your user interface design against those rules. And this could be this could require not you don't need to have like dozens of experts, but you just need a couple of experts if you want to really get serious. But usually, since they have a predefined set of heuristic rules, so that they go through and identify those problems. And it's also good in terms of if they identify the problems, they can point to the rules predefined, so you can fix those problems easily. So which is basically making your changes to comply with the rules. So so it might take lesser time because you don't have to invite all the users and so forth. But it could be also limited to the heuristic rules they have. So if some of the problems that is not identified in the heuristic rules, then might not be identified. So the other disadvantage is that you need an experts who are quite familiar with those heuristic rules, so that without having to always refer to those heuristic rules, they can kind of do the testing by themselves, so forth. So this is an example of some heuristic rules, especially this is by Nielsen. And this catches quite many of the aspects of the usability of user interface design. Some of the examples, like the first one is visibility of the system status, which means how much your user interface is telling you in what process it is, such as if it's processing something in the background, does it provide a progress bar, and so forth. The second one, saying match between system and the real world. I think this also kind of applies. I think one of the examples talking about this is the knob in your fridge and your freezer. So in many, I think these days they might have changed, but in old days, when you have a refrigerator, you had a fridge and a freezer, and then there is two knobs selecting how cold they are. And usually one of the knobs is dependent on the other. Usually the knob on the fridge is dependent on the freezer. So if you make it freezer too cold, then it actually affects the freezer. So the user interface is kind of two knobs. You set them independently, but in the real world, they are kind of interrelated. So if that's happening, what's happening behind the curtain is different, then user get confused, and usually you have to carefully adjust those knobs and try it out, and you might find out it was totally different from what you expected. So that's another kind of example. So I won't be going through all these heuristics. I'll just let you read through those the slides after the class. So if you want to check your user interface against these heuristics, you can do it by yourselves. So that's one way to do expert-based usability testing. And another way is to do, this case is called cognitive walkthrough, which is more focusing on the task that user has to do. So in this case, the experts list out the task the user has to do, and then they go through each of the tasks, and where they actually try out each of the tasks with your user interface. And while they try it out, they go through these kind of questions, asking at first, will the user try to achieve the right effect, which means if the user wants to do certain tests, then let's say with the word processor, the user, for the first test is to change the color of a certain word. Then the first thing the expert thinks of while he's doing the test is the user, is it obvious enough that user has to first select the task and then go to the menu system and choose certain menu item to change the color and so forth. So try to understand if if the user interface is obvious, that shows how to do the task in subtask. And the second question is, will the user notice the correct action is available? So if the user has to choose some action buttons or the menus, then are those menus visible when they are trying to do the task and so forth? And then the third one is if that button does the expected thing. So sometimes the buttons are labeled in different, in appropriate word. So user might think different functions, even though it's for another function it's actually doing. And then after they perform it, does it see the feedback, or is the if it's a time-taking task, then does it show the progress report and so forth? So it basically has a list of tasks, and then they go through each of the tasks and try them out. And while they do them, they go through these kind of questions and see if there any problems in the user interface. So those are the kind of two main approaches when the expert tests your user interface, which is yourselves can do with your user interface design. Okay, and the main, but again, there are certain limitations with the expert-based testing, and in the end, you might have to test your user interface with the actual user so that you can identify more general issues. So user-based testing is to invite a set of representative users and then let them try out your interface and identify the usability issues or problems so that you can fix them. You can also apply them at the early stage of your project, such as using paper prototypes. So it doesn't have to be a solid prototype, but you can use paper prototypes or non-functional screen mockups to test with users. And of course, at the later stage, you might also test with more functional prototypes. So as the user evaluation, you can kind of group them into formative testing, summative testing, and validation testing. And the formative testing, you can use paper-based prototypes and use Wizard of Oz technique, which is kind of having yourself or another experimenter to help kind of play the role of the computer or the mobile device. And in this case, you mostly focus on how the user interface are perceived by the user rather than how fast they do things, because it's no sense to measure time completion task or so if you are really acting out with a paper prototype, which doesn't make sense. But it's more like how visible are the menus in the screen, and if it's placed in the right place, or does the user understand which button to click and so forth. In the summative testing, if you have more solid prototypes and you have design alternatives, then you can test them and see which one is making more sense or performing better. And with the validation test, of course, if you have more solid prototype almost done, then you can validate if it meets to a certain level of goals that you set at the early stage. So how many users do you need in usability testing? Nielsen, which is one of the big names in usability testing, says that usually 5 users finds approximately 80% of the whole usability problems. So it makes sense, like this is a graph that shows this is the number of users that you invite to your usability testing, and this is the percentage of the problem identified by those users. And as you can expect, as the number of evaluators grows, they will find out more problems. But it's highly likely as you go beyond 5 or more, then it might kind of saturate, that they might not notice some of the very subtle problems. So So kind of makes sense that it kind of, but again, it's not that 5 is enough. So it's just saying if you have kind of around 5 number of pupils, then you might be able to identify most of the problems. So it all depends on how complex is your user interface, or how much time and how much research you can have for recruiting participants in your study. But anyway, the more is better to identify the problems, but it's on the other way around. In some cases, if you had already like 7, 8 people, then it might not make sense to have like 20 more to identify the same problems again. And usability testing, again, the goal is to find the problems. So it's to be practical, to find out those problems. So it sometimes, in many cases, it ends up like less than 10 people in the usability testing. And usability testing usually happens in this kind of laboratory setting. Unfortunately, we don't have this kind of setting at lab, which is kind of 2 rooms, 2 separate rooms, separated by a kind of half mirror, so that the user evaluators or the observers kind of sits behind the mirror and sees, and let the user sit inside the other room and let them use your user interface. And while they use them, you kind of monitor them using a video or screen capture, or even just observing how they use them, and then identify the problems they're having. And also they can do it in a workplace or home if that's more relevant. And they also sell kind of a kit. They come with a camera that they can put in the workplace or home, and then record them, so forth. And also there are some kits that you can do this kind of test remotely. But again, the laboratory-based usability testing is more widely done. And when you do a usability testing, it's not just throwing your user interface and let them try it out whatever you want. But more like you have a set of tasks, which is a representative task or main task that you expect user will do with your user interface, and let them try your user interface given the test list, and try to achieve those tasks and see if they are failing to use your interface to do the certain task and so forth. And when you create your task list, of course, you'll have to be more clear and unambiguous so that they can understand them to do that. And in some cases, it's good to provide a background scenario rather than just throwing them a list of tests, and maybe a kind of introduction of why you are doing this test and so forth might be useful. And also, a couple of things you might need to consider is if there's a certain test that has to be done in order, then make sure it's in the correct order. Otherwise, users might get confused which to do which one. And if some of the tasks, think of what happens if the user fails at certain tasks, then are you going to let them skip all of them, or are you going to help them to achieve that task and then let them go to the next one, or so forth? So you might have to think of those kind of rules, how to deal with when participants totally fail how to do that task. And also, if the time, test completion time is an important measure, then also you might need to think of if you're going to give a time limit. And it might be useful if some of the users kind of keeps trying, but taking too much time, like taking too much time with one test, then if you're going to let them stop that and move on or so you might need to think of those beforehand. And in many cases, usability testing focuses on quantitative measurements rather than qualitative feedback. Of course, you can collect the qualitative feedback afterwards when they finish those tasks. But while they are doing the task, usually quantitative measures are more common, which is three common things are task performance or task performance, which means how many tasks they successfully achieved or how accurate they did. Time performance, how much time they took to do the task. And afterwards, even with the qualitative feedback or the subjective feedback, you usually do it in a questionnaire, such as system usability questionnaire that we've talked about last time. And while you can collect the qualitative measurements after they finish the task and after that usability testing session, you can also let them can collect some qualitative feedbacks while they're using it. So one method is called think aloud, which is basically encouraging the participant to talk out why they are doing what they are doing, and what they are thinking, and so forth. But it also could be a problem that since we don't do certain tasks while we talk everything out, so the participant might not be familiar with those, and they might kind of be more disturbed, or they might have some problem with focusing on the task and so forth. So kind of could be useful, but choose wisely whether to use that or not. So I think it's more common that you use a reflection section, which is after they finish the task, and then ask why it is. And also it might be useful if you have a video recording, then where if you have a reflection section afterwards, then you might point into why did you did this task at this moment, and so forth. So again, if you during the testing session, you might have to decide in advance how to handle certain situations, such as if they are stuck at certain tasks, then are you going to let them stop or let them skip, or are you going to provide the solution, and so forth. Again, make sure to remind the participant it's not them being tested, but the user interface, so that they won't feel like being a mouse in an experiment. So, and to do that, it's always important to encourage them by letting them know they're participants in the usability testing is important to make the product better. And if video and audio recording is possible, then of course you'll have to ask their consent, and then make a recording so that you can refer to them later on. And with usability testing, you have a little bit more freedom of changing problems. So if one person found out certain problems with your user interface, such as if he or she pressed a button and it crashed, then you're pretty much allowed to fix those problems, and then make those problems fixed, and then with the next person those problems fixed. Because the main goal of the usability testing is to identify the problems. So it's doesn't have to be always the same user interface that you throw to each of the participants. But this is not the case with the user experiment. We'll talk about that later on. So after you've done that, you collect the results. So if you measure some test completion time, or if you have measured some usability questionnaires, then you do some statistics. But there are two types of statistics tools, which we'll talk in the next lecture. But again, this usability study is more focusing on the descriptive investigation of your user interface, which is mainly describing how much usable is your interface or how much it is not. So it's not really comparing two different alternatives and saying this one is better than the state-of-the-art or so. And once you've collected those, you write up a report so that that report could be given to the designer, or if you're the designer, then you can refer to those reports and fix the problems afterwards. So that's the usability study, and the next part of the lecture will be talking about the experimental study. So I think we still have some time, so we'll go through a little bit more. So compared to the usability testing, which is focusing on identifying the problems and fixing those, user experiment is more like a method for academic research of HCI. So as an academic research is to, the purpose or the goal is to discover new knowledge. So to come up, so as an academic research, you come up with a new way to interact with a computer, and then you kind of prove yourself that the new way you invented is better than the state-of-the-art, so that this new way, which is a new knowledge, could be generalized into the HCI field. And the main, another major difference is user experiment is so-called hypothesis-driven. So when you plan a user experiment, you always start with a hypothesis. We'll come back to this, what hypothesis is, in the later slides. But it's basically the research question you test with your user experiment. And in many cases, it compares multiple conditions, and especially the state-of-the-art and your new idea or your new design. And the main purpose is to discover causal relationship, which is if you change the user interface into a new way you thought of, then does it affect the user performance or the usability level and so forth. And since it's trying to discover new knowledge and to be more used in general, it should be replicable or generalizable. So it's more thrives to remove errors while they do the user experiment. And it also uses statistical tests to make conclusions and back your findings. So to briefly compare the usability testing, again, user experiment. So most of the methods you use in both of the type of user study might be quite similar. So you still use observation or key logging or usability questionnaires and all the quantitative measurements such as measuring the time, test completion time, or count the number of errors. Those are all the same. But the main difference is the goal between them. So usability testing is to identify problems and fix them. User experiment is to answer the research question, which is mainly if you have a new idea of interacting with computer, and then you are trying to prove your idea against the state-of-the-art, which is how we do it now, and to prove that your idea actually makes difference. So other types of differences, usability testing again needs fewer participants, such as if you have 5 or so, you mostly achieve your goals, which is identifying the problems. But user experimental study, you might need more participants because this is all about how generalizable is your study. So in many cases, it needs like 15 or 20 or even more participants. And so usability testing is to improve your design in many cases. But experimental study is usually for validating your idea. So it's most likely happens at the very later stage of your research. And again, in the usability testing, you might want to control, such as giving them a list of the tasks and so forth. But you could be flexible, like fixing some of the problems that's critical for the rest of the study. But in experiment, it's has to be always the same setting between the participants so that you can collect them into a statistic way, and then make generalization out of general conclusions out of it. And usability testing is more like when you develop a product out in the market. So to make your product more usable so that you can deploy into the market. But user experimental study is more like an academic way of research. So during your MHIT course with your project, I think you might need both of them in mixture. So while you develop your design, you might do some usability testing. But in the end, since it's an academic program, when you write your thesis, you might have to validate your ideas are actually making difference from the previous state-of-the-art technologies. So the difference between the two could be also identified in the procedure that you do the study. So this is a kind of outline of the study. You set the goal, both of the study, you set a goal, let the user use your solution, you collect qualitative and quantitative feedbacks, and then analyze them and then report back. But the main difference is at the middle. They still do the specific test in both of the study, but with the usability testing, usually there is only one condition, which is your design and which you want to make improvement. But the experimental study, you have different conditions, which is one could be the state-of-the-art way you interact with, and the other should be your new ideas that you want to validate against. And we'll come back to this later, but when you have different conditions or solutions, we call them, these conditions is independent variable, and the feedback, you call it dependent variable. I'll explain it more in the later slides. So in the user experiment, these are the main things that you have to consider in addition to what you've already considered in the usability testing. So first, you'll have to establish the research question, which is written in a form of so-called hypothesis, which is basically a prediction of outcome. So which is a sentence that says if you change the interface, the user will perform faster, or if you change the interface, the error will be made less, and so forth. And with the experimental procedure, there are certain techniques or methods that you might want to apply. So we'll talk about those. And then also, when you answer to the research question, which is the hypothesis, you test the hypothesis using statistical tool. So we'll talk about this part in next time on Thursday, but we'll be focusing more on these first two part of planning the user experiment. So before we go into details, I think we will have to start learning some of the new terms that is specific to user experiments. So first is there are many different types of variables. And the main two variables is independent variable and dependent variable. By independent variable, we are mentioning the possible cause of the change in dependent variable. And this is called independent variable because this is independent of what user does or participant does. On the other hand, dependent variables depends on what user does, which means the test completion time, number of errors made, those are dependent variables. Independent variables are the tools given to the user, such as if you had two interfaces, then the interface is an independent variable. And try to not confuse with the independent variable with the conditions. So the conditions is, so for instance, if you have an interface as an independent variable, you might actually compare more than two interfaces, which is three conditions. So if, let's say you are, again, a developer of Kinect at Microsoft Research, and you are going to compare it with already out there game console, which is Wii, and maybe the PlayStation was invented later, but anyway, let's say PlayStation was already in the market. So, and the Kinect, and you have three different interfaces, which are three different conditions you let the participant try out. but it's one independent variable, which is the user interface. Okay, and you can have more than two independent variables. So for instance, let's say, again, you are using three interface. Let's say Wii, Kinect, and Sony PlayStation Move, and all those are capable of 3D interaction, right? So you can put one independent variable as these three interfaces, and you can put another independent variable as different tasks, such as pointing or translating, moving the object, or rotating or scaling. Those different tests could be another independent variable, so that you can test if one interface is better on this task, the other interface is better on that task, and so forth. So in that case, there are two independent variables, which is one is interface and the other is task type. But the conditions might be different. So in the interface, you can have three interfaces. In the task, you can have another three sets of tasks. And the number of condition is actually the factorization of the two tasks. So if you have 3 and 3, then you will end up with 9 conditions that you have to let the user test. So typical examples of independent variables are the first category is related to technology, which is mainly the interface the user use. The other independent variables you can think of is related to the user, so you can compare different age groups or different genders, see if females are performing better than men or so. And the level of computer experience, compare if the experts are better than novice, or which interface is better for novice and which bit is better for experts, and so forth. So those are another category of independent variables you can try. And the third category is related to the context of the use. Could be time of the day if you're testing the visualization of the map in the navigation, then you can test if it works well during the daytime or during the nighttime, and so forth. Those kind of context could be also another independent variable that you can test. And the dependent variables, of course, these might be kind of categorized into, if you remember the slide talking about different aspects of usability, those kind of aspects could be mapped into these kind of measurements, which is dependent variables. So you can measure efficiency using task completion time or speed, how fast they can do the task, so forth. Accuracy with how much error they made while they do the task, or subjective satisfaction, such as ask them to rate how satisfying with the user interface, and so forth. So you can think of those measurements we talked about. And there are also other types of variables, or the terms that is used in experimental studies. And one is so-called controlled variables, which is the variables that you control in the experiment. So if you think if you designed a new interface that is you thought is good for noisy environment, then you can control the noise level to a certain level. So you don't necessarily change them between the conditions, but you just make it constant between the conditions to make it even throughout different conditions. So that is called controlled variables. Random variables is those variables not controlled, such as how tired the participant is. You cannot really tell how tired are those, or if they slept how many hours before they participate in the study. You cannot really control them. So those are random variables. This might affect the study, of course, but it's more ideal if you can control the variables as much as possible. So if you can make many of the variables controlled, that's more ideal. But there are certain variables that you cannot really control anyway. So since there should be a certain number of variables, and since we are relying on statistical tools, it's always important to randomly assign your participants in different conditions. Otherwise, some of the groups of participants who are very tired could be assigned to one conditions, which will end up with getting biased by this random variable rather than the conditions you actually wanted to investigate. So that's it. I think we'll stop around here, and we'll go through a little bit more details about the hypothesis and the user experiment design. So we'll have a 5 or 10 minute break and then come back at 11 to continue on the hypothesis. You could refer to those kind of categories and see if which are relevant to apply to this, but it's not always kind of direct application, but you rather have to customize those. Okay. So coming back to user experiment, so if we kind of boil down the user experiment to what it means is it becomes basically testing your hypothesis, which is so the whole purpose and the goal of the experiment is to test your hypothesis, whether it's wrong or correct. So it's important to set a proper hypothesis, so that which is the very starting point of your user experiment design. So by the term hypothesis, it means a precise problem statement that can be directly tested through an empirical investigation, which means experiment. And compared with a theory, which is a bigger chunk of knowledge, hypothesis is a smaller statement, probably in 1 or 2 sentences, and more focused statement, and can be examined by a single experiment. So let me go through a little bit more slides and give you some examples. So, and the main feature of the hypothesis that it has to meet is it should be able to be proved or disproved. So if you have a statement, then if you can rather decide if it's true or false, then that's one of the conditions that the hypothesis needs to be met. But if you formulate the hypothesis and you find out there are some cases that could be neither true or false, but there should be another case, then that means your hypothesis has to be modified so that it always can be concluded true or false. So, and it has to be clearly defined, so that since it's all about testing if it's true or false, it has to be clear that everybody agrees what does the hypothesis mean, and it should have appropriate scope, and the main words or main components in the hypothesis should include is the independent variable and the dependent variable. So let me give you an example. So these are some of the typical examples of HCI research hypothesis, which is first one, for a pointing task, this is kind of defining the what was it? Scope, yeah. So this is defining the scope into a pointing task. And then there's a significant difference in mean test completion. So this mean test completion time is being a dependent variable that you are measuring, right? And then that difference in mean test completion time between the V and Kinect. So V and Kinect, this type of interface is the independent variable. So it has an independent variable, dependent variable, and it defines a kind of scope, what it's interested in. And it's kind of clear enough. If you read this sentence, then you understand we are expecting the V and Kinect. If you use them, it might end up with different tests. One might perform faster or slower when you do the pointing task. The second example, similar one, we show significantly less error compared to Kinect when doing pointing task. So again, we have V and Kinect, which is 2 interfaces as an independent variable. And then here we're using error, pointing task. And of course, if you want to be more specific, that you can put here like if it's a geometric error or if it's a count of number of times making errors or so forth. And again, it puts the scope of what you're focusing on. And again, as you can see here in both of the sentences, you see this significant word, significant difference. It's significant less error or something, so it's significant. This is a term used in statistics, which means it's not by chance. So you can think of this significant means it's not happening by chance, but it's meaningful. So as the user experiment is all about proving or disproving your hypothesis, if you think of proving an hypothesis, it's always almost impossible to prove it's correct in an empirical way. So if you want to prove something in an empirical way, you'll end up needing to check all of the cases that the statement you've made is true. But if you think of the other way around, of disproving a certain concept, it makes it easier in empirical study, because if you get one case that is against your statement, then you can easily disprove the hypothesis. So again, if you're using an empirical way, this is again saying I'd like to emphasize it in an empirical way, which is through a user experiment, not in a kind of logical deducive logical way, but an empirical way. It's easier to disprove something than proving it. So scientists came up with when you have something you want to prove, it's hard to prove it in an empirical way. So they negate it and put it in the other way around. So they introduced the concept of null hypothesis and alternative hypothesis. So first we'll go with the alternative hypothesis, which is the actual hypothesis that you want to prove. So if you want to prove that Kinect takes lesser time than V, then your alternative hypothesis will be Kinect will take less time to do certain tasks compared to V. That's your alternative hypothesis that you want to support. But since it's hard to prove this case, you negate the term and make it into a null hypothesis, which should, as an example, it should be Kinect is not much difference compared to V in terms of task completion time and so forth. So it's basically, if you have come up with a certain hypothesis, then you have to invert it to make a null hypothesis, and your purpose of your user experiment will be disproving that null hypothesis, so that you can make a conclusion that your alternative hypothesis is supported. Okay. So again, an example with the three user interfaces. So if we are a Kinect or developer, then we want to say that a Kinect is faster to interact, so the task completion time is smaller. Then the statement or hypothesis you want to support is the second one, which is there is a difference in task completion times between the three. So that's the alternative hypothesis. But since we cannot really prove this easily using empirical study, we make a negation of it, or an invert the sentence, saying there is no difference in task completion time between vMove and Kinect, and that becomes a null hypothesis. And using the user experiment, you kind of try to find a statistical evidence that you can disprove this H0. And although I've been using this proof and disproof wordings, maybe I'll talk after this. I was going to say. So the goal of the experiment is basically finding statistical evidence to reject the null hypothesis, so that you can support the alternative hypothesis. So you might notice that I didn't use the word prove or disprove. So since we are using statistic tools to find if the hypothesis is true or false. We cannot use proof or disproof. So because statistics is everything. I mean, it's all about chances, right? So it's all about chances. So again, we cannot really say it's solidly proven or not, but it's all about saying about chances or percentage of how likely it is. So we use different words such as reject or retain, which is if you are against certain idea, then you say you are rejecting that hypothesis. And if it's supporting it, you say you retain or you keep the null hypothesis and so forth. So if you can reject your null hypothesis using statistical evidence, then you can support or confirm the alternative hypothesis. So, and since we are using this kind of statistic tool, there comes a problem with sampling. So say this is the population we have, and let's say red dots are those supporting our hypothesis. Say those when we invite them and do an experiment, they will come up with performing faster with Kinect than we. And let's say for some reason, maybe it could be because of they're tired or whatever reason, these blue dots, let's say if we experiment with them, they show not much difference between the two. And if you see the whole population, if we can experiment with the whole population, then we can conclude that the red one, which is saying there is a difference, might be more likely. But if we kind of sample this part, and since we cannot really invite all the users and do the experiment with them, we'll have to sample some of the participants out of the users. And if we sample by accidentally this part of the population, then it might lead into different conclusion, which in this case seems like there are more blue dots. So you might end up with concluding that there's nothing much different between the two. So you might have to be aware of these kind of situations. So it's always likely that it's better to make sure when you sample the participants, you try to sample them from a variety of populations rather than a certain group of users. And again, since we are sampling from the larger population, we can make errors, such as if you sampled this, then it's an error, right? Right. The truth is actually the red dot is the more relevant truth out there, but because of the sampling, we end up like the blue idea is correct, and those are error. And there are two types of errors we can make when we test the hypothesis, and they are called type 1 or type 2 errors. And they are defined in this way. So let's say in reality, H0, which is null hypothesis, is true. And in this case, is H1 is true, which means let's say that we are comparing V and Kinect, and H0 is saying V and Kinect is not much different, and H1 is saying Kinect or V is much different from the other. So say if this is the reality with all the population, and we sampled and did our user study, and we concluded we reject the H0, which is we are saying H0 is not true, even though it's in reality is true. This type of error is called type 1 error, and it's also called false positive. And the chance of making this type 1 error is called alpha. Okay, so this is again a probability between number 0 and 1, and which is a chance of making type 1 error. And the other type of error is, of course, if you reject H0 when H1 is true, then that's a correct decision, and the other way around is a correct decision as well. But if in reality with all the users, there is certain difference with the two interfaces. But if you do run a study and then you conclude that null hypothesis is retained, which means you found no difference between the two in your user experiment, then that becomes a type 2 error, which is called false negative. And the chance of making that kind of error is called beta. So the reason why I'm talking about this alpha and beta, those are the terms that you come up with certain statistical tools. So you might need to be aware of alpha and beta when we talk about alpha and beta is related to type 1 or type 2 error. And in many cases, especially in HCI research, and not only in HCI research, but in general, when you're running an experimental study, scientists are more interested in this alpha level, because if you have invented a new interface, and if you say it is much better than the state of the art, and if it's but in reality it doesn't, it's they kind of want to prevent that kind of false error more actively. So it's kind of being very conservative. So if somebody invented a new idea or new theory, then it's trying to minimize the error that making that theory, the new theory, being accepted by the whole society of scientists, rather than having this error, which is, it might be the new idea actually the truth, but in certain studies you might not find that actually has any effect. So anyway, in short, it's more an important issue in an academic field to make sure this alpha level is low enough so that we don't make these kind of errors. And I think I've just explained that. And to make it as low as possible, usually 5% or sometimes 1% is kind of a commonly adopted level of alpha that which is a chance of making errors, type 1 errors. So let's come back to hypothesis testing. So to test a hypothesis, you kind of run a study and measure quantitative feedback and crunch the numbers using statistical tools. And in many cases, the statistical tools as an outcome gives you a p-value, which is basically a probability value of how likely is your H0 is true. Okay, so again, let's go with an example of Kinect and V, comparing those two, and your null hypothesis will be there's no difference between the two. And what the p-value means, and if you run you measure the task performance and you put it into a statistical tool and it printed out the p-value. What the p-value means is that assuming the H0 is true, the probability of likelihood we are supporting rejecting H0. So this is basically, p-value means basically how likely it is making this type 1 error. Okay? So this p-value is this probability of making this type 1 error. So if this type 1 error, probability of making this type 1 error is very low, then we can say we have, by rejecting H0, we're not making, there's a very low chance of making this error. So this should be a correct decision of that we made out of statistical tool. Does it make sense? It's a little bit complicated with all this null hypothesis and alternative hypothesis. But anyway, if you ran a study and it printed out a p-value, you are expecting the p-value be very low, which means the chance of making this type 1 error is very low. So we can say the decision we made with rejecting H0 is highly likely it's a correct decision. Okay? So the whole purpose is to support this H1, right? And reject this one. And and again, p-value is the probability of making this type 1 error using statistical tool. So and since p-value is just a probability value with the number between 0 and 1, again, scientists kind of made an agreement that if it's lesser than 5%, it's kind of likely acceptable, or if it's if p-value is less than 5 or 1%, it's kind of acceptable. So this level or the reference of being compared against is called the alpha level. So if and usually you'll have to set this alpha level in advance, and in many cases in HCI research we just set the alpha level to 0.05, which is 5%, or in some cases, if you want to be really conservative, then you set it as 0.01, which is 1%. And in your report, you usually mention that we set the alpha level to 0.05, and the p-value was less than 5%, so we conclude that it's significant, which is, we don't think this is an error. And so, again, in a nutshell, you ran a user study, put those values into statistical tool, it prints out the p-value, and you compare the p-value to an alpha level you previously set, and if the p-value is lesser than alpha, then you say you find a significant result. And by significant, we mean it's not by chance. So let's go with an example to get a little bit more consolidated understanding. So let's say, again, we are comparing V and Kinect, and the null hypothesis we set was there is no difference in mean test completion time. And you tested and observed and calculated the mean completion time, and the mean value came up with V, the user was taking about 100 milliseconds to do the task, average. With Kinect, it turns out it took about 500 milliseconds to do the task. So the difference is 400 milliseconds. But we'll have to see if actually this difference is statistically by chance or because of we chose those random the participants from those certain groups, or if it's actually generalizable to the whole population. So use a statistical tool called t-test. So we'll come back to these different types of tests in the next lecture. But anyway, so the t-test is for a statistical test that compares the two mean values and see if and prints out the p-value. So let's say you typed in those numbers and ran the t-test and printed out p equals 0.04. So if the alpha level we set was 0.05, which was if 5%, then this 0.04 is less than 0.05. So we conclude that, assuming there is no actual difference in population between interacting with E and Kinect, the probability of observing a difference of 400 milliseconds sample is only 4%. Basically, what this statement is saying about is the chance of making this error is only 4%. So we are not really making this error because it's likely that it's only 4% of chance that we might have made this error. So we are saying this is not an error of rejecting H0. So we're making correct decision of supporting H1. Okay. So since it's 0.04, which is less than 0.05, the alpha level, so we conclude that null hypothesis rejected, which means there is a difference between the two interfaces. So in the case of no significant result, which means p-value is higher than alpha level, then we conclude that the null hypothesis is retained. So we cannot really say if there is a difference between the two. So we retain them. In case of significant result, which means the p-value is lesser than alpha, we can reject the null hypothesis and accept or support the alternative hypothesis. But again, using this statistical tool, we don't say we have proven it or we have disproved it or so. We have to use the term that we have retained or rejected or supported or against the hypothesis, because this is all about chance, not really a solid conclusion. So one catchy thing, although you might have to consider, is statistical significance is different from meaningful difference. So even the statistical significance is always meaning that the chance of making this error. So it's not even you found that that error is very low, like in this case, we observed this is meaningful difference. I mean, this is significant difference that it has about 400 milliseconds. But being meaningful, like is 400 milliseconds really a meaningful time? So if it was a game application and pointing certain targets, and if it was the task completion time difference was 400 milliseconds, which is very small amount of time, then although statistically significant difference was found, it might not be much meaningful in under the context of being on game interaction device. But if you think of it was a brake pad interface that you've newly designed in a car driving, then 400 milliseconds could be a very meaningful difference. So again, statistical significance is always all about if we are making, it's saying, what statistical significance is saying is how much of chance we have of making an error, but it's not really saying about how meaningful is the difference. So you'll have to look into the actual amount of difference and see if that's actually meaningful under your context. And the other thing you'll have to be aware of is if you have found, using a statistical tool, if you haven't found any significant result, that doesn't mean that two interface is equal. So all we can say if we haven't found a statistically significant result, the conclusion should be we cannot really say if there is a difference, but we cannot say they are the same. So this is mainly because of the statistical tools we use are designed to be in that way. So there are other types of statistical tools that you can actually test if two are the same or not. But in many cases in HCI research, since in many cases we always want to prove this new idea is different from the state of the art to make an improvement. So most of the statistical tool we use is always about deciding if there is a difference or not, but not much about if two is equal. So be careful of writing up your paper saying, since the p-value was higher than 0.05, we can conclude that interface A and B is same. We cannot say that. We just say we didn't find an evidence of being different. So I think I've almost covered the slide. No, I think we have some of the slides left. So I think I'll leave this activity as a homework, but necessarily not as a homework you have to submit, but just as an exercise, think of what kind of hypothesis you might have in your user experiment. And I think I'll give you an assignment next week with the statistical tools. So then I think I might ask you to actually write up what is your alternative hypothesis and what is your null hypothesis. So maybe it's good to start thinking of those. So I think we have about 20 minutes left. So I think we kind of boiled down everything into a user experiment being testing your hypothesis. So how you formulate your hypothesis and you test that hypothesis, putting in your quantitative measures into statistical tool, and then it prints out a p-value, and then with the p-value you can actually make a conclusion whether your hypothesis was rejected or retained and so forth. So that's kind of a big overview. And we'll dive into more details about how actually we should be running the experiment. So another aspect of running the experiment is to design the process of how you do the experiment. And of course, you first start with formulating your hypothesis. But there are much more details you have to consider when you design an experiment. And always it's easier to start, and obviously you might have already formulated your hypothesis, and in your hypothesis you might have identified the independent variable and dependent variables already. So first thing you'll have to consider is how many independent variables and conditions you really want to test in your user experiment. Because if you have you might have many different aspects of your experiments, but it's more easier to have less independent variable. You can have as much it's not that problematic if you have many dependent variables, because you can pretty much run the statistical tool, statistical test again and again for each of the dependent variables. But if you have more independent variables, then you might end up with not really being able to analyze the results using a statistics tools. So, and also it means how many conditions the participants have to experience. So let's say if, coming back to our example of, if we are going to compare only Kinect against V, then we get the participants, and while we are running the experiment, we let them try the same test using two interfaces, right? If we had 3 interfaces, then they have to try all 3 interfaces, which will make them need more time. So if you say for each one condition, it was taking about 10 minutes to finish. If it were 2 conditions, your experiment will finish in about 20 minutes. But if it were 4 or 5 conditions, then it will take longer time, which will make the participants more tired. And being tired, it means you are introducing a random variable which affects the results. And you might not be able to draw generalizable conclusion. And the other aspect is, so again, independent variable is not exactly the condition. So independent variable, in our example, having 3 different interfaces, the interface itself is the one independent variable with 3 levels. And the other independent variable we can think of is if we are designing it against comparing, let's say, 2 age groups, elderly people and young age group. And if you're going to compare those two, the age group is another independent variable. And to test them, you'll have to factorize them into 6 conditions, which means one condition is using V with young participants, and another condition is V with older generation. So you have to factorize them, so it's basically multiplying them. So as you add more independent variables, the number of conditions kind of grows exponentially. So, so in many cases, I won't recommend having more than 2 independent variables. So if you have more than 2 independent variables, such as 3 independent variables also, the user experiments gets quite complicated, and you might end up with too many conditions that your user experiment will take more than an hour. Then that will mean more of a trouble of recruiting participants who are willing to spend more than an hour with you being a participant. So it's definitely more practical if you have 1 or 2 independent variable, and not too many levels within the independent variables as well. And while you design these levels in the independent variable, you might have to think of a baseline condition, which is basically meaning the state of the art. So if you fill all the conditions with your own user interface, so let's say you've invented both, let's say you invented 2 new gaming interfaces, and if you just compare those 2, all you can say is there are 2 alternatives I've newly designed, and one is better than the other, but it's not really comparing against the state of the art, which is people are already using it. Then you can't really say your new idea or your new interface is better than the already existing interface. So it's always important that you include a baseline condition, which is state of the art, in your one of your conditions. Otherwise, you might end up like, so what? So that's one thing you'll have to consider. So the other factor for designing user experiment is how you assign your subject or participant in your condition. So if you have decided your independent variables and you factor it out into different conditions, then the next thing you have to think of is are you going to let each of the participants to try all of the conditions, or are we going to let one participant to try only one interface or so? And this has pros and cons between the two designs. So the first one, which is actually I think it's the other way around. I'll explain the bottom one first. So within group design is where you have each of the participants try all three conditions, which means you have one participant and then let them do the same test using Wii, Kinect, and PlayStation Move. So you let them try all the three conditions. The other option is between group design, which means you invite your participant and you let the first participant use Kinect, you let the second participant use the Move, you let the third participant use the Wii, and compare it in that way. So that's called between group or between subject design. And in some cases, the within group is also called repeated measure, and this term is the same, basically meaning the same, but within group is more of a term that you use against the how your experiment is designed. So you say it's a within group design or between group design. This repeated measure is more used in identifying the statistic tools. So there are certain statistic tools that is designed for within group experiments, and that's those types of statistical tools usually have a word saying repeated measure something test, ANOVA test or something. So again, this is important because these two designs, depending on which design you take, not only you will end up with, you'll have to use different statistical tool, but it means how many participants you really have to have. So if you have your study in a between subject or between group design, it will avoid interference with learning effect, which means within subject design, the user might do the same text with different interfaces. So as they try the first interface, they might learn a little bit about how to effectively or efficiently do the task. So when they move on to the next interface, they might have learned something. So they might actually, not because of the interface, but because of they are trying it the second time, they might improve with their performance. So that's not good because that's again affecting the results. But on the other hand, within subject design, since they have to try all the conditions, it will take more time for each one participant. On the other hand, between subject design takes lesser time for at least for each participant. And since and the other important difference between them is it's more easier to find a difference between the conditions with using within subject because since each of the participants is trying all three of them, they can easily compare the three, right? So, but if participant A, but if you were using between subject design and all different participants tried different conditions, then if you directly compare them, there is another factor which is there is a difference between the subjects, right? Some of the subjects might be good at the test and some of them might not be good at certain tasks. So there's a chance that it's likely that it might be also introduce more variability or variance. So it's harder to detect difference between the conditions. And in that sense, since it's introducing more variance, it's likely that you'll have to have more sample size, which means you might have to have larger number of participants when you use a between subject design. And so in many cases in HCI research, you go with within subjects as much as possible. And if you're having too many conditions, then you want to reduce the the time of the experiment for each participant to not to introduce some being affected by fatigue or participants getting tired, then you can assign some of the independent variables as between subject. And actually, this within subject design and between subject design, you can decide for each of the independent variables. So you don't have to have all the independent variables in one way or the other. So, and some of the independent variable actually has to be always between subject. So for instance, if you are comparing the difference between the gender, so if you have made an interface and if you're interested in looking into if female or male is better with one interface or so, then the independent variable of gender cannot really be within subject, right? No one can be male and female at the same time. So you cannot really have that independent variable as within subject design, but you'll have to go with between subject design. So there are some independent variables that has to be one or the other. And so I think I might have been missing one of the slides here. I'm missing one slide. Oh well. Can't think what was it. Oh, I think it was about mixing those two. So if you have more than one independent variable, then if there is only one independent variable, you can simply go with this way, and you formulate the number of conditions, whether 2 interfaces or 3 interfaces you are comparing. Then you can pretty much define if you go with between group or within group, which means are you going to let each participant try all of the conditions, or are you going to assign one participant to one condition and the other participant to another? So you end up with just choosing one or the other. If you have more than one independent variable, then as I've mentioned before, you might end up with some of the independent variables using between subject and some of the independent variables using within subject. And those kind of mixed design is called split plot design or just mixed design. And again, depending on this different design you go with, you will have to use different statistics tools. So thinking of the within subject design, which is each participant trying all 3 conditions, again, the main problem with that is learning effect. So as the participant try the first one, they might learn something, and the second one will be affected by what they learned from the first condition. So to balance out that effect, we can actually randomize the order which condition the participant tries out. So to do that, you can basically randomize the order. But if you have small number of conditions, which is highly likely with your thesis, there is a technique called balanced Latin square design, which is balancing this order in a certain way. And this balanced Latin square is basically a matrix form of numbers or conditions. And by Latin square, we mean each item occurs once in each row and column. So for example, in this case, A appears always once in each column, in each row and each column. So each of the conditions always appear once in each condition. But there could be different cases. We want to also, but the balanced Latin square adds another condition, which means each condition, not only it occurs once in a row and once in a column, but also each condition the order it comes is kind of balanced. So let's go with the second example, where if you try to look at A, in this balanced Latin square, A comes only once, appears once in a row and once in a column, but it also, half of them if you compare B with A, half of the cases A comes before B, like this row and this row, and the other half, I think this is actually a wrong example, AB, AB. Oh, yeah, I was looking at the wrong example. So this is a Latin square, but not a balanced Latin square. So in this case, A comes before B for 3 times. And there's only one case where B comes before A. So this is not balanced. So if you make it balanced Latin square, it becomes like this. So in this case, again, A always appears once in each row and once in each column. But in this case, A comes before B for 2 cases, like this one and this one. And the other 2 cases, B comes before A. So this is a Latin square design. So if you have 4 conditions, you go with this design. So the first participant uses the interface in an order of A, B, C, D. The second participant tries it in B, D, A, C. And the third participant tries the condition in D, C, A, B, A, this order. So use this balanced Latin square design. And there are, I think if you Google, there will be some websites that prints out balanced Latin square for certain number of conditions. So you can do those too. And if you go with between subject design, it becomes very important to randomly assign your participant to different conditions, because if you might intentionally assign certain groups into one condition, then you might end up with not getting affected by different factors rather than the conditions you had. So it's always important to randomize which condition you are going to assign the user study. And this is kind of table that shows you how much important is the random assignment is. And again, with a user study, if you have no multiple conditions, it's not called experiment. It might be a usability study, usability testing, but it might not be an experiment. But even if you have multiple conditions, if you haven't done random assignment, then you might end up not being a proper experiment. To sum it up, so this is a kind of an overview of the process that you do, a procedure of your user experiment. So if you go with between subject design, you gather subjects, which is participant, then you have to randomly assign each subject into different conditions. You gather the data and do the statistical analysis. If you go with within groups design or within subject design, you recruit participants, and then in this case, you're not randomly assigning them to different conditions, but you are randomly assigning them to different order of them trying the conditions. And if you have more than one independent variable, 2 or 3, then you can go with factorial design. So for each independent variable, you can have different number of levels or different number of conditions, and you can mix the between group and within group factors for each of the independent variables. And also a good thing of having more than one independent variable is you can study the interaction effect, which means if one factor affects the other. So as an example, if you're comparing mouse with a touch screen, this is one independent variable, which is an interface. And you can compare 2 groups of participants, which is one being a novice user and one being an experienced users. And you can see here from the graph that for novice users, touch screen was performing better, but expert users, the mouse was performing faster. So as you can see here, some of the independent variables could kind of being affected with another, basically interact with another independent variable, and you can also make conclusions out of those. But the more the independent variable you have, the more complicated factors you have to think of and interpret. So again, I won't recommend having more than 2 independent variables because that will make you quite complicated in looking into different effects. So as a rule of thumb, if you go with between subject design, you might need like 15 to 20 people per condition. So if you had 3 conditions, that you'll have to multiply it by 3, so you'll end up with like 60 participants you might need. But if it's within subject design, each participant is going to try all 3 conditions, so you will just end up with needing about 15 to 20. But again, these numbers are just a guideline, just a general rule of thumb. It depending on how much of difference you are expecting. So if the measures that you measure with the dependent variable, if you're expecting big difference, then you might end up with significant difference even with a small number of participants. But if you're trying to detect a very subtle difference between the conditions, then you might need more participants to reduce the variance of your experiment. And to do that, in a statistics tools, there is a tool called power analysis, where you put in how much of the expected difference you have, which is an effect size, and how much level of alpha and beta you are expecting. Then it prints out how much participants you need. But in many cases, this prints out quite a high number. It's definitely a good tool that you can use if you want to make sure how much number of participants you need. So when you finish your study, then you might have to check if your study is valid or not, and see if how much of generalization you can make out of it. So you can think of 2 different types of validity. One is internal validity, which means how much you made sure the random variables are controlled, so not other random variables affected the study. So that's called internal validity. The external validity is how much generalizable is your participant, so which highly relates to how was your sampling of participants where happened. And sometimes this is a trade-off thing, but always ideal is to make sure your internal validity as high as possible and external validity as well. And even though you kind of try to control as much as possible, it might still have some random errors, because we are all kind of sampling the participants and relying on the statistics tools. There are certain variants, but these kind of random errors could be minimized by getting more participants. But if some of the designs were having certain systematic problems, then they could be biased. So these kind of errors cannot be corrected even if you have more participants in there. So to reduce those kind of biases, make sure your measurement instruments are correctly calibrated. See if your experimental procedure is biasing in certain ways, such as one good example is if you didn't apply Latin balanced square design, then it might be biasing certain conditions to be better. And the status of the participants and experimental behavior try to be equal in each condition when you do them. And always a good thing to make sure those errors are not happening or biases are not present is to run a pilot test, which means just testing your experimental design with small amount of participants first. So it's a kind of trial run of your experiment, and see if everything is working and fix those design problems of your experiment and before you do the actual testing. And another good way is to standardize your procedure, which means write down what kind of procedure you are going to go through. So if you write down the steps of your user experiment, then it will help you to be consistent between the participants and so forth. And that also helps you to have multiple experimenters. So if because of your schedule, if you want another student to help your experiment, then if you have a written procedure, then you can pretty much stick to the procedure so they can have another person look after your experiment as well. So typical experimental session, you first ensure your system and device is all working, and you bring a participant, greet them, and introduce your purpose of the study and what they have to do in this experiment, and get the consent form, and then assign the participant in specific way you've designed, and then let them before they do the actual test, there is a high chance, since you are introducing new interface, it's always good to have a training test so that they can get familiar with your user interface. And then you let them do the actual test and measure the time and error and so forth. Afterwards, you can also collect subjective feedbacks using questionnaires. And then, where did we go? And then you, if you want to do some interviews, then you can have some interviews afterwards, and then reward them if any. So I think we've already mentioned quite a lot about being nice to the participants. So, and it's always important to have an informed consent, not only for the participant, but also for yourself. And as an experimenter, always write down your instructions so that you can just simply read them to them and so forth. Checklist could be also helpful. And again, if you have those kind of things, then you can have other people to look after your experiment, so that could be easier. And while you do the experiment, if you find some odd things, that if some of the participants actually was cheating with the task, like doing different, introducing new way to do the task other than using the proper way to use the interface, then you might have to make sure you take a note of them so that afterwards when you analyze them, make sure you know that's a special case. And of course, if you did the experiment and you found out the logging software didn't work, then that's a disaster, because you cannot really put that participant again and do the experiment again, but it will take another time. And try to take plenty of photos and video recording. It's always good to have those, because when you analyze the results and you find some odd things, then you can go back and see what happened back then. But it's also good for having it in your report, so to have some pictures. And of course, you'll have to make sure, since it's a problem of privacy, you'll have to make sure the participant agrees with you to put them into the report. So that's it. So this is kind of a brief overview of what we've went through so far. I won't repeat. But so in the end, so experimental study is very good for making very well-structured or formal assessment of your new interface design. But it's not always perfect. So it still has a limitation in terms of, since we are always relying on measurement tools, such as some of them could have some problems. And also, since we are relying on statistical tool, we cannot really make a solid conclusion, but it's always a chance that there might be some errors in our study. So it's always good to have more than one measure and compare them with each other. And some of the measure it might be ideal if you have some of the objective measures and subjective measure and mix and see if they support each other, and also if you can have some questionnaires or interview at the end of your study and collect some qualitative feedback, then you can see if those comments actually matches with the findings you found from the statistics. And also, even if you found a significant result from one experiment, it doesn't make that's a solid scientific truth, because science evolves and theory changes over time. So even if one researchers have found certain findings, another researcher might do a similar experiment, and if the finding is supporting the previous study, then that will become more kind of general theory that people accept. But if it's conflicting, then they might investigate it further. So that's all for today. Sorry, I've ran over about 10 minutes. So that's what all about the usability testing and experimental design. So it's actually next week, but next time. So on Thursday, we'll talk about the statistical analysis you can do. So once you've run the study and you've collected the numbers, and we'll look into what kind of statistical tools you can use for analyzing the results.